Okay, this is one of my favorite exhibits here at the observatory. This is a demonstration of eclipses and how the moon moves around the Earth and will be eclipsed by the Earth, and then will also eclipse the sun. So the Earth is tilted on its axis, and you can see that in the diagrams here, but the moon doesn't orbit the Earth in the same plane as the planetary ecliptic. So it comes up above and down below. If I look up above here, they've got a nice model for us. You can see the moon orbiting the Earth. As it comes around, we're going to watch it. You get a better view of how the moon comes above and below, but not straight across. So in the center, there's our sun shining a big bright light. Now you can see there's the moon going below, and is it going to eclipse? Nope. It comes above. No eclipse. How about this time? It's going to come around and it's going to eclipse? Oh, there was a little one. You saw the shadow on the surface of the Earth. How about this time? No, no shadow. It missed completely. You can watch the moon as well. When it goes around the back, you have to look to see if there's a shadow cast on the surface of the moon when it passes behind the Earth. So it's coming around again. We'll have another look. Here we go. Let's watch the moon this time. New moon, full moon. No lunar eclipse that time. New moon. Here comes the full moon. Still, there we go. Good lunar eclipse that time. Will it fall in the shadow again? No, a little bit. And we'll take one more look. Tiny bit. So lunar eclipses are much more common than a full solar eclipse. And this is why. It's because the moon is much more likely to fall into the shadow of the Earth as it moves around behind than it is to pass just right in front of the sun, in between the Earth and the moon, Earth and the sun. We'll see one more time. You can see the eclipse as it casts a shadow on the surface of the planet. There it is. One more time. Do we see another one? No shadow that time. So with each orbit, there's not an eclipse every time. Only when things line up just right. And here, we can see how things have to line up. And here they miss. And there they line up. And there they miss. So things only line up just the right way a few times. Let's look at the next exhibit. Oh wait, we've got a little diagram here. It's going to show us. There's a solar eclipse coming and going. It says solar eclipses are spectacular events. I can't wait to see the next one. I missed the one this year, but I am going to the next one. Oh, that's great. Look at that. That was from 2002. Now this is going to show us a lunar eclipse. And the lunar eclipse, it's going to cover it with a shadow, and then it's going to turn into a color. You see that color? Each time the lunar eclipse is unique. And now it turns into a shadow again and passes away. Because the light of the sun curves around the Earth, there's still a little bit of light that will land on the surface of the moon. And because we see it through the atmosphere, and atmospheric conditions are different each time, every lunar eclipse is unique. And once you have the full eclipse, you get what's called luminaries on the surface of the moon. I'll watch the solar eclipse one more time. The luminaries are sparkles on the surface of the moon that show up in a full eclipse. And each time they're unique. Okay, let's look at our next exhibit.